All right, so we just looked at the time of flight and the horizontal range, and essentially what we said was that we had a cannon that fired at 30 meters per second at an angle of 40. And we looked at the whole path of this particular object here. Now, in the second worksheet, we ask you to take a look and try to determine how high this thing goes. So in the very first worksheet that I showed you with the example there, we did the full trajectory and delta y was 0. But if we are doing this particular problem and trying to figure out how high it goes, we want to make this our starting point, and then as it moves up, we're going to make this our final point there. So essentially, what's happening is we're looking at it halfway through, and we still want to be in components here. So they're going to be just like last time because we made the numbers the same. This is 30 meters per second at an angle of 40 degrees. So just like in the previous problem, if you break this down into a horizontal velocity, you're going to get 22.98 meters per second to the right, and the vertical velocity was 19.28 meters per second in the upward direction. Now what's going to change here is this time window. It's not 3.93, and delta y is clearly not 0 anymore. Delta y, it's much higher than it initially was. So this is actually what we're trying to solve for, is delta y at this point here. And in order to do that, this is going to bring back some stuff from the previous unit that we've done here. Delta x, I have no idea. Time, I have no idea. And then we know what VYI is, we know what G is. We don't know what delta y is. VYF, this is where it gets a little bit tricky. Our initial velocity is pointed up in the vertical direction. But what you're going to find is that as you move through this trajectory, the horizontal velocity is always the same. It's unaffected by gravity. But the vertical velocity, anytime our objects are rising, they have to slow. So it's going to shrink. And what ends up happening is that the velocity up here is 0. So we want to set VYF to 0. And then we have 3 out of 5. And what you're going to find here is that we actually don't need to consider the x direction to get our maximum height. In fact, if you remember from the previous unit, the time independent formula was the one that was the easiest to work with to get our max height, and it's the same case here. So if you take a look and I write out the time independent formula, what you're going to see is that we have everything except delta y there. So that's 0. This is 19.28. We square it. We have 2, negative 9.81, and our unknown of delta y. So it's as easy as simply solving for an unknown. And if you end up doing your algebra properly, I think you get 18.94 meters as your maximum height here. So what you're going to find is that pretty easy to do. In fact, we didn't, in this particular case, even have to consider the x direction in order to do that. The key point to both of these example problems is this, and I can't stress this enough. If you're given an initial velocity at an angle, it can never go into those formulas. You always have to be in components. So you need to break it down into an x velocity and break it down into a y velocity in order to accomplish that.